China just revealed a terrifying breakthrough that could blind stealth jets mid-mission. Their new 6G-powered electronic warfare system doesn't just jam radar, it creates thousands of fake targets and transmits battlefield data at the same time, using the exact same frequency. For the first time ever, jamming and communication happen simultaneously in real time. If true, this could shatter the radar advantage of F-35s and tip the balance in future conflicts. Let's break down how and why it changes everything. At the core of this innovation is a completely new kind of system, one that can carry out high-frequency signal interference and data exchange using the exact same frequency band. That may sound small, but it's actually a major step forward in how advanced electronic systems operate. Most traditional platforms require separate hardware and spectrum allocations for sending data and for disrupting or deceiving incoming signals. This new 6G-based technology blends both into a single, seamless process. The key lies in a microwave photonic core. Instead of relying solely on electronics, this system integrates light-based photonics components that can process signals far faster and more precisely. A special optical fiber loop stores radar-like signals for just fractions of a millisecond, enough time to manipulate them and send them back out. These return signals appear as echoes, tricking advanced detection systems into seeing fake objects, up to 3,600 of them at once. What makes this more advanced than past systems is its full-duplex operation. It can receive and respond at the same time, using just one frequency range. That means there's no need to switch channels, separate tasks, or carry extra bulky equipment. And because it's based on photonic technology, it's smaller, faster, and more efficient than earlier generations. Another key strength is its networked capability. This system isn't isolated. It can link with hundreds of other platforms simultaneously. It collects data from different sources, shares it in real time, and applies coordinated signal responses across the entire network. That creates a shared picture of what's happening in the electromagnetic space. All of this is housed in a compact, intelligent platform that's already been tested in prototype form. The system has shown it can handle dense data flows, quickly adapt to new signals, and deliver precision-level responses, all while keeping a low energy profile. The leap forward here is the integration of what used to be separate functions. Instead of jamming, spoofing, and communication happening in isolation, they now exist together, managed by a unified system that adapts in real time. One of the most talked about aspects of this new system is how it could affect high-end radar technologies, especially those used in stealth-enabled platforms. These radars, operating in the high-frequency X-band, are built to be smart, using rapid signal hopping, advanced encryption, and tight signal control. But the 6G system is designed to meet those challenges head-on by introducing intelligent interference and deception techniques. Instead of blocking signals entirely, the system floods the radar with highly accurate simulated echoes that are designed to look like real detections. With over 3,000 of these signals generated per second, even a modern radar can become confused. When too many false signals are introduced, it becomes more difficult for the radar's software to determine what's real and what isn't. Unlike traditional signal blockers that simply overwhelm systems with noise, this 6G platform matches the radar's own operating characteristics, timing, frequency, and even polarization. This precise matching is what makes the deception effective. Because the system reuses the same spectrum that the radar is scanning, the false signals blend in more easily, slipping past digital filters and confusing even the most sophisticated signal processors. This becomes even more critical when we consider that modern stealth platforms rely heavily on data fusion, pulling together information from radar, infrared sensors, and communication links to build a complete picture of the surrounding environment. If one of those key inputs, like radar, is compromised, it can throw off the entire system. A radar that's unsure of its input leads to hesitation in decision-making and reliance on less precise alternatives. Moreover, this 6G-enabled system isn't just a tool, it's a platform. It can share information across multiple systems in real time, meaning the simulated echoes it generates aren't random. They're coordinated across different users, creating a much more convincing and consistent picture that can mislead or delay response. The broader implications of this new 6G-powered system go far beyond one radar type or one aircraft model. What we're seeing is a complete transformation in how signal environments are managed, where data sharing, detection, and signal manipulation are all happening at the same time, using the same tools, in a coordinated and adaptive way. In traditional systems, communication, monitoring, and interference each require their own dedicated setups. But with this new design, everything is integrated into a single smart system that reduces size, weight, and complexity, key advantages for future platforms that need to operate with agility and flexibility. What's especially notable is how the system supports large-scale networking. With links to over 300 separate nodes, it can share updates and instructions across a wide area, making the entire network more adaptive. This allows for real-time responses to changing signal patterns, which is essential in any rapidly evolving environment. It also reduces the lag time between detection and reaction, giving users an edge in signal clarity and coordination. The use of photonics is another major shift. While photonic technology has been explored in research labs for years, this marks one of the first times it's being applied in a practical, multifunctional format that's ready for larger testing and possible future implementation. Its use allows for faster processing, greater bandwidth, and higher resistance to interference. As a result, other countries and organizations are likely to accelerate development in areas like AI-assisted signal processing, multiband verification, and cross-platform sensing. New standards may emerge that focus on ensuring data trustworthiness even in the presence of intelligent interference. This development suggests that the future of signal management may be less about brute force control and more about precision, speed, and smart adaptation. With the integration of high-frequency photonics and AI logic, signal environments are evolving into dynamic ecosystems, ones where responsiveness, not just power, determines performance. Ultimately, this new system sets a high benchmark. It doesn't just challenge existing designs, it opens the door to an entirely new way of thinking about how electronic systems sense, share, and respond, quietly reshaping the landscape of advanced technology without ever making a sound. What China has introduced with the 6G-powered system is more than just a new tool. It's a complete rethink of how advanced technologies can operate together in one unified platform. By combining real-time signal disruption, ultra-fast data sharing, and intelligent coordination, it challenges long-held assumptions about how communication and detection systems work. The use of photonics, full-duplex operation, and synchronized signal networks marks a major shift, not just in design, but in strategy. As the world moves toward more connected, more dynamic electronic environments, systems like this are likely to become the blueprint for what's next. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.